freeze so that I can see what's going on. Okay. So the first thing we have to find is the curl. So we're going to do curl. So we're going to do curl f. I, J, X, Y, Z, X, Y, Y, Z, Z, X. Okay, so you get 0 minus Y, and then you get negative Z minus 0, and then you get 0 minus X. All right, so for the curl, I got negative Y, negative Z, negative X. Is that what you guys got for your curl? Yes, no? How? Oh. Okay, did you all match the curl? Your N is the gradient of the vector if you were to write it normal. So I get 2x, 2y, 1. Good. So we match. Good. Looks like everyone's got that far. All right. Okay, so we're going to set up the double integral. So curl off f dot n would be negative 2xy minus 2yz minus x. Oh, and okay. So I'm just going to start with the dy dx first. So remember that it's over the area of the projection of the surface onto whatever plane you're talking about here. This is solve for z. We're going to project onto the xy plane. So we get x squared plus y squared equals 1. If I wrote it dy dx, I would go negative root 1 minus x squared positive root 1 minus x squared, and x would go negative 1 to 1. But I'm pretty sure this would be easier to do in polar. How did I get this? Yeah. It's at curl f dot n. Do you dot product? Okay, let me pause. Okay, we're only in the first quadrant, first octant, which means we're not going 0 to 2 pi. We're just going from 0 to pi halves. And then our radius is 0 to 1. All right, I'm going to use a couple steps here. So negative 2 times r cosine theta times r sine theta minus 2 times r sine theta, and then z is 1 minus r squared. So times 1 minus r squared, and then minus r cosine theta, dr d theta. All right. So cleaning it up. So let's see, we have negative 2r cubed sine theta cosine theta minus 2r sine theta plus 2r cubed sine theta minus r squared cosine theta. And your stuff cancels. Whoops, the r theta. That's an r. All right. Let's see. I don't see anything fun to get rid of. All right, well, let's just integrate. I'm going to pause for a second. Did we all start with the first line, or did I mess up? That's what you got? All right, that makes me happy. I'm just going to do the R's and see what happens. So. Should I combine like terms? I'm going to combine like terms. I hope I didn't mess up anywhere. Sine, cosine, minus 1/2 sine, minus 1/3 cosine. Beta. All right. This guy requires u substitution. If you think about it, the sine is like your u and the cosine is like your du. So this is really just kind of like the integral of u du. So this would be 1/2 u squared. So you get negative 1/4 sine squared plus 1/2 cosine minus 1/3 sine. So let's see what we got here. So sine of pi halves is 1, so you get negative 1/4 plus 0 minus 1/3 minus 0 plus 1/2 minus 0. So I get negative 1/4 minus 1/3 minus 1/2. So you're going for 12. So 3 plus 4 is 7, plus 6 is 13. That's what I got. Aubrey got the same thing!
No, I didn't. I got negatives.
Oh no!
I missed the 1/2 somewhere. So can you go up?
I got negative 17 over 20.
Can you scroll up so I can see right?
Well, yours was right?
Oh,
Do you
wait.
have the same numbers though as me?
Yeah, everyone has the same numbers.
Okay, so then So we got to figure out where I messed up then.
No, I messed up.
I think I messed up too though.
Oh.
So it'll be good. All right. How do you have different? Oh, because I'm in. No, wouldn't it show up
It's
red?
the same.
Yeah,
It's exactly the same. Okay. All right. Did you get the same curl? Did we get the same n? Okay. Did you get the same curl dot n?
Yeah.
Yes? Okay. So when you converted to, did you convert to polar?
Yes.
Okay.
I see.
So, yeah, I know. Okay. So, let's see. I'm going to look at my own too. I have negative 2 r sine theta minus 2 r sine theta 1 minus r squared minus r cosine theta all times r. Negative 2r cubed sine cosine. Oh, I found it. I found the mistake. That should be an r squared. R squared. There we go.
4, so
This
4.
one's fine. Oh, nope, you're right, to the fourth. I stopped multiplying the RN for this term. Fourth. And then this one's right.
Yeah.
Okay. So I just paused to multiply my R and then got back to it. All right, so let's see. So this becomes negative 2/3 R cubed sine theta. And this becomes 2/5 R to the 5th. There we go. All right, so we have -1/2 minus 2/3 plus 2/5 minus 1/3. All right. So combining like terms, negative 2/3 plus 2/5. So times 5. Negative 10 plus 6 is negative 4/15. Negative 4/15 sine theta. All right. So we end up with positive 4/15 cosine theta. And everything else is the same. So plus 0 plus 4/15. All right, let's see if this gets me the right answer. If I did my math right. Negative 2/3 plus 2/5. I just combine these terms.
All right. I did them separate.
All right. So 1/4 plus 4/15 minus 1/2. All right. So now let's do this. Out of 60. So let's see. Times negative 15 plus 16 minus 30 over 60 equals negative 20. I got negative 29/60. Still no?
I got negative 17.
All right, where am I messing up? Negative 4/15. Okay. Oh, whoops. Nope. Plus 0. Oh, I erased this and I shouldn't have. All right, I gotta stop trying to do this partial. All right, here we go. So, negative 1/4 plus 0 minus 1/3 minus 0 plus 4/15 minus 0. All right, now we get negative 1/4 minus 1/3 minus 4/15. All right, so out of 60. So negative 15 minus 20 minus 16. Let's see, negative 50. I still get negative 51 over 60. Oh wait, but that reduces. That's negative 17/20. Is that what you got? Yes. I can do math. Oh.
What do we have to keep it as like this? It's not by the fraction. I have this.
That's fine. Although, I need to warn you guys, your final says you have to simplify all answers.
What?
And it says it in big, bold letters on the instruction page.
I'm doing it.
But you get a calculator.
Oh. Okay, the same one.
Wait, we get a
Your chapter 16 test is no calculator, but your final exam is calculator. Yeah. Okay.
Wait, do we
So-
have to simplify on the chapter 6? No?
Backing up. Okay, quiet down. So backing up, are there any questions? I know I had to like back up and redo a couple things because I didn't multiply in my R. So are there any questions about applying Stokes? It's just curl f dot n. Curl f dot n. How do we feel about Stokes? We're all kind of getting it. Amal, how you doing? Are you okay?
Yeah, I'm just looking at it.
Okay. All right, the last problem is divergence theorem. So divergence theorem, remember, is just the integral of the divergence, but you're integrating over the volume instead of the area. This one, if you notice, it's sideways. You're going between the planes x equals -1 and x equals 1. So when you actually go ahead and just get started. But when you integrate, you're not going to do it where you have a like polar with a dz. You're going to do it where you have a polar with a dx. Good. Yay. So when you're doing divergence, divergence is just the dot product of the partials. So d dx, d dy, d z dot with f 3xy squared xe to the z. All right, so my divergence was 3y squared. Oh, whoops, dot product. It's not a vector. It's a scalar.
Oh my gosh.
Okay. Let's see. Plus 0 plus 3z squared. So I get. All right, so if we think of this as a cylinder that is kind of cutting through the YZ plane instead of the XY plane, so then we would do, think of this as like, I'm going to jump right to it. So this would be 3r squared, and then dx, dr, d theta. My x's would go -1 to 1. My r would go 0 to 3. And my theta would go 0 to 2 pi. So it ends up being really pretty simple integral. So just the only difference is that instead of z -1 to 1, it's x -1 to 1. So you end up kind of doing an x with the yz's. So anyway. I know you can all work this out. 0 to 3. So you'd have 3r cubed x. Zero to 2 pi. Oh, whoops. From -1 to 1. So, 0 to 3. 3r cubed minus -3r cubed, or 6r cubed. So 6/4. I'm just kind of doing this by myself. Whoops, I keep not writing my numbers. -3 to 3, 0 to 3. All right. So it equals 0 to 2 pi. Let's see, so that's 81. 243 halves minus 0. D theta. So I get 243 theta 0 to pi. So I get 400, well, I just, let's just do 243 theta. 243 pi. I got 243 pi. Which is what you got when you used my numbers. Yeah. So then we know we're right. A regular surface integral is just f dot n. Remember, it's the one where you do the negative partial x, negative partial y, but I always just do regular n. So I just did the integral of f dot n over the area of the projected surface, the surface projected onto the xy plane, and just did a whole bunch of math. But it worked out just fine if you want to practice one of these. So other people are doing this using divergence theorem, which looks so innocent, but apparently does not make your life easier. I'm going to pause this and put it in an 89 and see.